It's on, is it? Okay. Okay, welcome everybody. As I crash down there, just technology. Hope I haven't done anything wrong. My name's Paul Bonsack. I'm the Managing Director of IAPMO, and I wanted to welcome everybody here today to our inaugural Plumbing and Gas Product Information Session. We're also joined on a webinar, so I welcome all the people that have joined us electronically from all around the world. I have to say, I'd like to thank the Master Plumbers Association and PICAC and the unions for all working together to be able to make this possible. I mean, we've got this amazing facility here that's enabled us to come together to learn about products and try to improve and enhance the plumbing industry. Now, most of us know a lot about Master Plumbers Association. We know a fair bit about PICAC, but a lot of people aren't aware of who IAPMO is. Now, IAPMO, we are the International Association of Plumbing and Mechanical Officials, and that's a mouthful, but basically we're a certification body and we're the largest in the world for plumbing certification. And in Australia, we do testing and certification under Watermark, which you'll all be aware of, under Gasmark, and under the Oceana mark. Now, the Oceana mark is a mark that we use for product that doesn't require certification, but people want their products to be certified to it to make sure that their products are safe and compliant. So that's the mark that we work under. Now, we also, besides doing certification work here, we also have a gas laboratory. Now, this gas laboratory is based here, just on the other side of that wall, actually. And it's it's a purposely built and the most advanced and sophisticated gas laboratory in Australia. So it's the only purposely built laboratory, and it works. So we have it works in very leading edge technology, and I'll talk about that in a minute. But we also work with Watermark test laboratories in Australia. And we have representatives here, Prove, who we have a great working relationship with. And we work with laboratories all around the world, depending on where the clients are. That's annoying, that thing. Sorry about this. Right. Now, IAPMO, our parent company, is a not-for-profit organisation that's owned by its plumbing members. We in Australia work on the same principles. And IAPMO started 95 years ago, I think it was, and it was started by a bunch of plumbing inspectors that wanted to get consistent regulations and standards across the states of America. And it's something that we've been chasing in Australia for many years, this national consistency. So they got together 95 years ago and started up this International Association of Plumbing and Mechanical Officials and set up standards and certification, and this business has been running ever since. About 25 years ago or so, a fellow called Russ Cheney came along, a plumber, a plumbing contractor, and he joined as the CEO. And Russ had this vision of growing and developing IAPMO internationally, which he did very, very successfully, turning us into the largest plumbing certification organisation. And he's done an outstanding job. Russ retired just before Christmas, and his role as CEO has been taken by Dave Viola. And Dave is in the same theme and has the same vision that Russ had. So, and they've had a number of years to work together to make the transition. So now we have heading it up is Dave Viola, and they do an amazing job. Now, one of the things is, being a not-for-profit, what do we do with our money? Because we make money. And we put all the surplus that we make back into the industry. We put it into raising the sanitation conditions of people, and I used to say in third world countries, but I no longer say that, because we've worked in America, and we've worked in, as you can see there, the Navajo Nations Project, and we're doing some work in Australia. So it's not third world countries we're looking at. But what it is, it's we're working with people just to help them raise their sanitation, the sanitation conditions of people who need it. One of the best stories I have about IWISH, the International Water, Sanitary and Hygiene organisation, is that many years ago we heard a story about a school in India where there were young children going to the toilet. They had a couple of toilets there, but the toilets weren't connected to anything. They just flowed onto the ground, and the effluent was just lying there. So the young children had to walk through the sewage to go to the toilet, and of course they didn't do it. So the little boys went to the bushes in the corner there, and the little girls went to a paddock next door. And what we heard was that there was being some issues with transient men and the little girls. And once Russ heard this, he said, no, that's not going to happen. So we sent some of our guys, including one of our guys who lives in the northern parts of New South Wales. I call him Indiana Jones. Grant Stewart, because Grant wears the hat and everything. And he flies in. He's a plumber. And him and his team organised, and Sean and the team from My Wish organised with our sponsors of people all around the world, clients and others, who put money and people and time and assist us to do this. And we undertake what we call as community challenge, whereby we go in there. And with this Indian project, what we did is we created a bank of toilets connected to a septic. We put in hand washing equipment for the children. We put in reticulated water. We put security fences around, which was wonderful. And at the end of it all, we were standing around feeling wonderful about what we'd done, and these children were washing their hands, and they all walked out holding their hands together. And people thought that they were saying, thank you. And so I said, no, they're smelling the soap and saying, doesn't that smell great? And it made everybody feel really warm and wonderful that we're able to help them. So it's something that we work in. So again, we're not just about making money. We're about the industry, and we work together with our partners, Master Plumbers, PICAC, the unions and other organisations to better enhance the, I'm getting told to wrap it up. Okay, so now just very quickly, here we have the laboratory that I was talking about, and we have the leading technology in there. This is stuff that hasn't hit the market yet, that we're testing and certifying. And over here we have one of the most advanced plumbing schools in the world. And what the intent is to bring these two together. This is where technology meets training. And this is a wonderful thing that the industry's been able to do together. Now, and this is what we're doing today. So without any further ado, I'd like to introduce the first of our speakers, Mr. Zan Jiang. Zan, and our second speaker will be Mr. Peter Faze from Dux. But I'll pass it over to you, Zan, if I may. Thank you. Sorry.
Yep.
Yeah, my friend.
Okay. Thank you. Thank you. Good afternoon, ladies and gentlemen. First, thank you to IAPMO and Paul for this opportunity to present and introduce Total. My name is Zan, and we're from the distributor, Total Distributor Australia. Today, we're going to cover 3 topics. First is Total about the quality and quality control. Second, easy installation and how we're going to connect the washlet. And third is the backflow prevention and risk assessment study. A little background on Total. Total established in 1917 as a ceramic toilet manufacturer, and for 100 years to today, this is the history map and development. Iconic thing is all Total factories are still majority owned and managed by Total. And in 1980s, Total invented their first washlet product. And in the 1990s, the first neo-rest, which is the integrated toilet, has been invented. So we say it's over 30 years and almost 40 years time for this product to be introduced to the world. And now I would like to talk about how Total performance is product quality control to ensure that all products are made and delivered to meet the highest quality standards. So in the 1980s and 1990s, the production line was focused on large-scale automated assembly and production. It was suitable for single model mass production. So we have here for one unit, one model mass production. And then we see the demand start to change. And in the early 2000s, split into smaller groups making different units in the factory. And then in the latest decade, we see the demand, it makes start to like a soft production, a mix of production and units in one assembly line. Yep. Here, we take a detailed look at how Total controls the quality of production and ensure that the level of quality is consistent. Total uses cameras and monitors along the production line, and that takes videos and photos. All these videos and the photos are collected and being checked manually every day. So that will help to detect any missing parts and also ensure a consistent level of quality and avoidance of unnecessary waste. So moving forward, the quality control system start to use the QR code, which have been widely adopted by using a central database system. Any raw materials or parts received can be checked to ensure, so the first stage can be checked to ensure that it meets the quality requirement. Then the system record and store the data. The goods now move to warehouses for storage. And the QR code is now using for the location and the spot. While the received goods move to the production phase, where the QR code is used to ensure that all materials and parts are correct and match the production plan list. So during the production, the QR code is used to scan and check the parts after every stage. This is done to ensure that all products are traceable and correct. So if there is a missing step, the unit will not be recognized and allowed to move to the next step. And finally, when goods are ready to dispatch, the QR code is now using to ensure all the right units are delivered to the right location. So by using the QR code and passing the product parts through the various production stages, quality is guaranteed. Total wash is traceable. So if there's a call for a warranty service saying there's a missing part in the box, lots of time we can say it is traceable, and we know whether this is due to a careless on the site lost, or it is due to a missing in the box. So in the second section, I would discuss how Total wash lids are connected. Before we introducing the connections, we would like to reference the current standard, which is the AS 3500 clause 12. It says all douche seat need to have RPZ valve installed. So, oops. Then move on, we're gonna say how it is connected. So we have a demo here. I'm gonna show you the steps how to connect to the wall, to the water supply, and to make it run. So actually it is no difficult than install a normal seat. The few steps going to follow, very straightforward. Connect the junction, connect the base plate, then mount the wash lid, connect the water supply hose, check the power plug, and give a trial and ready. So I will move here. So we assume this is an installed toilet already done, because the toilet is all same and things. For wash lid, what we'll need here, can show it to introduce a T. That is for a closed couple toilet. So normally there's one short valve that supplies for the toilet. Then for the wash it needs a separate water connection. So we will install that to connect. Yep. Then move on is the base plate. So the standard toilet for Total, the good thing, it is always convertible. It can be used as connect as a soft close seat, but also a wash lid by using a special rubber bolt. Put the rubber bolt in. Oh. and this, I'll call it the base plate. If Gary can give me a hand. So we'll put the base plate here. Yep. Just gently mount. Yep, that's all good. Move on here. I'll wash it, then take out from the box. That's the one. So it is a seat. It's a smart toilet seat. Then gently pull on to check. Yep, when we hear the click, it's been installed. Now it's not the final stages, it's halfway through. Then we check the distance, where they need to move forward and backward. This time I'm very lucky, it's right in a good position. Screw it. Yep, here is it, using a dismount unit, and take off. Tighten up the bolt, and then put it back again. Yep, that's correct. Then move on, we need to connect the hose for the water supply. So it is worth to mention that it needs to install a drill check valve. So although the standard requires for RPZ valve, there's a requirement for the drill check valve. So we refer to the watermark standard WMTS 051, requires for douche seat with a low hazard backflow prevention unit, a drill check valve. So in our sample demo, it is a wall-face toilet, so it already got a in-wall system at the back. Not really near the tip, just to show you one goes for the system and the other one connect to where it is, and then connect the hose. Yep. This is, again, it's very important to follow the standard, the AS 3500. Okay, the step next is to plug in. We use a standard GPO here, Australia standard plug, get in, connect the power, turn on the washlet, it works. So the product itself is self-checking everything's right. The next one we see is check if there any leaking position from the valve, from the unit, from the washlet. Then everything's all good. We check the washlet functions. There's a little sensor at the side. You can see when detects people actually sit on it, not spray anywhere to mess the bathroom. Because for demonstration we don't have the water connected, we won't be able to show you how water comes out. But a little thing here is when slightly push here, we go for a trail, then we can see the nozzle come out and all the things is correct. And then everything's good. But it is worse, okay. Yep, check functions, everything's good to go. Now it's being installed. So that's how easy it is. Last part, again, refer back to the Australia standard AS 3500. This shows how the RPZ valve is installed and how it shall be connected to the washlet water supply to split to the normal water supply for the whole room and area. Yep. And we say Total follows the required standard, and we are deeply care about water safety issue. Nevertheless, because it is a very unique requirement in Australia for the RPZ valve, and because the rest of the world have all different requirements, so Total did some internal risk assessment study on backflow prevention, and we would like to share today. And the image shows a washlet nozzle. So that's a washlet nozzle when fully extended, and that's a toilet bowl. To make the very serious safety issue when we say the wastewater is being tracked back to the main supply, it is need to have few situations being satisfied. So the toilet bowl is need to be clogged with water, spray wand is extended to the bowl, spray function is activated, it's running, and the negative pressure occurs on the primary side. And it only can happen when these four situations accumulated happens at the same time. And for Total, the record is being accumulated, sold 100 million units over the world for 40 years. There's no accident being reported related to a backflow issue. So we see here, so here we did some assumption studies. To make this happen, we assume first abnormal condition 1, the toilet is blocked. And we assume, say, it's in a 1 in 1,000 chance to make it happen. Then the abnormal condition 2 is it's blocked and people keep using it and makes the toilet full of wastewater. That may happen in another 1 in 100 chance. Abnormal condition 3, when it is full of wastewater and people still try to use the washlet. We assume this is a very rare situation happen in 1 of a 10 million chance. Even for this, I think it is over exaggerated as per photo shows here. That's how it is. Toilet got an overflow. I do have some photos find from real life, but I just cannot share with you guys. If you're interested, you can do some research afterwards. So the user need to, despite the situation here, that waste is overflowed, and still try to use the washlet function. And because the washlet has a sensor detecting whether there's people sitting on there, so you need to sit on the washlet when it's overflowed and try to use it. Ignore all the things. Very, very hard. That's a hard man to do that. Maybe we say that's 1 in a 10 million chance. And last part is it needs to have a negative pressure from the main. So that may be another 1 in 1,000 times. So overall, it comes when these 4 abnormal conditions all fulfilled, have a probability of 10 in a negative 15 power times. So we say when we have a normal use of the toilet, spray of, we say if we have 100,000 units sold in Australia by each toilet using 4,000 times a year, with times the probability, it comes 4 times of 10 minus 7 power. Then it comes, say, equivalent in a 2.3 million times for 1 to happen. So next, we're gonna analyze the different method of preventing backflow. One is using a vacuum breaker, which currently Total is using. Unfortunately, it is not being recognized as a high hazard backflow prevention material. Then is we can have an inbuilt air gap. Here, we assume using a backflow a vacuum breaker. It gives 10 minus 5 times chance. And while using an air gap, that's 100 times more efficient, gives a 10 times minus 7, and plus the 4 abnormal conditions. Then in total, one method will give a 10 to the minus 20 times, and the other one is 10 to the minus 22. So when it's getting to very, very low chance, we see that probably not make many difference. So here we say why, we understand why that's needed for a backflow prevention using a normal bidet feed when the spray is underneath the ceramic, the overflow rate level. It will happen as long as the abnormal condition 1 happens. So when it's blocked and the negative pressure occurs, then the wastewater will go back. So in this situation, we definitely believe it is necessary to apply RPZ valve. Here we would like to share some information. This is the structure of design for a washlet, and the vacuum breaker is being built in the washlet. This is adopted for Japan, USA, and Asia market. And currently, USA and Japan performance on backflow prevention, different standard, same testing procedures, different criteria. And we say total has now passed in both both countries. Yep, thank you that's my presentation for today. Any questions?
I do, just a quick one.
Yep.
As you know, I'm a fan, and I've actually installed the toilets, and it is not that difficult. It's quite a simple process. So it's, but with the douche seat, I know that they're accepted widely in Asia.
Yes.
How have you found the acceptance in Australia by public? Is it something expanding and growing?
Initially, when we do the market research, we find there's quite many feedback saying it is a very different thing, very interesting thing, but Australians not get used to this idea, and it will take many, many years to get it developed. But we see actually in the last few years, there's a booming for the demand due to the people visit Asia countries, visit Japan, come back experienced, and also this is a very good product for a handless experience in the bathroom. So with the pandemic, we see there's a push for the acceptance of the washlet, and yes, total do find it is growing, and it's not only suits for the Asian country, Asian community, it suits for worldwide, for everyone.
Thanks. I actually have a question of Glenn, if I can. Glenn, with the backflow prevention, what's the resistance to accepting more international standards as accepted in Asia and the States and other places?
Things have been changing over the last couple of years. The Backflow Prevention Association of Australia and especially the Victorian chapter have been changing their views on it. We've even had one of the main proponents of having RPZ as an absolute minimum from the South Australian water regulator, Jeff Clark, who's actually just recently retired, was actually very supportive of reducing the requirement from high hazard down to even a medium hazard. And also that with the air gap requirement on it, that we can somehow classify that as a registered air gap by verifying the design.
My apologies.
That we can verify the design during factory inspections. That's being discussed. You had up on your board, your presentation before, a WMTS 051 2016.
Yep.
There's actually a draft ABCB watermark specification 51 2020 out for public comment.
Yep.
They've actually changed the backflow prevention requirement statement in there that shall be in compliance with AS NZS 3500 Part 1. Now,
So
3500 Part 1 for everyone
one, yep.
for their information, it's like a deemed to satisfy requirement, an informative requirement. And we are working, our IAPMO is working, trying to assist these type of units, because we can see that having these type of units be allowed with a lesser type backflow prevention device, what is that lesser type, and lower hazard rating, will bring us more in line with the rest of the world. For example, North America's backflow capital of the world. And if they accept a less requirement, why doesn't Australia? So watch your space. We are working with the regulators. We are working with the Centres Australia Committee to try and get these changed. Matt Wilson from the VBA is here. Matt's a regular participant in the Victorian chapter of the Backflow Prevention Association. So we are all working towards it. But at this stage, an RPG is still required.
Yes, thank you.
Thanks, Glenn. Thank you, Zan. We do appreciate it very much, and well done. Very, very interesting. Now I'd like to take the opportunity to introduce Mr. Peter Fays. Yeah, he's got great titles. And he's really important in ducks. So over to you, Peter. Thank you.
Just continue to click on. Oh, right. I've got to my start page. Thank you, Paul. Thank you for inviting me along. Thank you, IAPMO and those who put this show together. I'm just going to do a fairly quick presentation about just some of our product range, and then mainly the thing I want to focus on is some of the latest usage that information that we've been getting out of some of the products we have. So really the contact is product range, tankless solutions, and the latest usage. So just who are we and who do I work for? I work for Ducks in Australia. Ducks in 2014 was purchased by Noritz. Noritz is the largest manufacturer of residential water heaters for the Japanese market and has been doing it since, I think, 1951. Good friends of Toto's actually in Japan, so, both Japanese products. Yeah, so they sold over 2 million water heaters last year. In the R&D area, they have about 500 people working in there. We've sold about 5,000 in the commercial spectrum, and that's all I'm going to talk about, our commercial range, not our residential range. Sold over 5,000 water heaters since we've started, and manifold systems, which we'll talk of, we've sold about 800 of them. In the market, in the residential market, as you can see up on the board, we have the Noritz brand has about 40% market share in the residential in the Japanese market, but in the commercial market, they have 60%. They're certainly the market leader, and when you look at some of our range of products, you'll certainly see that that is the case. So this is the range that we're brought into the Australian market. We have a 28 internal and external non-condensing. We have a condensing range of 32s, which are both an internal and external, and we have a condensing 50-litre water heater, which is the largest continuous flow water heater in the market. That individual is based out of the Japanese commercial range, and that individual water heater is the number one selling water heater in the Japanese market. Of all the water heaters sold, it's approximately 40% or that 50-litre product. It's a really great product. We've got one out there with a few parts missing out the front, and Daniel and I can show it too if you want to have a look at it later. So it's a really great product. Then what makes Noritz products better? It's designed from the ground up. So we don't take a residential, we don't take a residential heat exchanger. They develop heat exchangers that are designed for commercial applications. So we have a 28 and 32 that are a certain size, and there's probably one out there, and we have a 50-litre, which is bigger walls, thicker fins, designed for long life. So I'm just going to talk quickly about our intelligent tankless systems and seamless hot water. So what we actually do is we put the tankless systems together, all these units, and here's some examples in both 28, 32 and a 50, and designed to make make them act like one water heater. So we have like the large one, we have a group of 8 water heaters there. That building, when it's running at 60 degrees, when there's no water being used and it's just on heat loss, one of the units does the unit work all by itself. It sits there and operates, and then the others are staged on as and when required. Right then. So it's modular. We can have up to 24. The biggest we've done, I think, is 10, but 10 50s is a lot of hot water. But yeah, a lot of them. And even though that is you might be able to deliver 12,000 litres, I can deliver exactly correct 2.5 litres of hot water, up to 12,000. So just like one water heater, except many all added together. And then, so how does the tankless system work? So what we do is we have 2 real sections that drive it. The first thing is we have an individual water heater starting right up the top on the top, left-hand side. You have one unit and it will work by itself, providing the load up until the burner capacity reaches 60%. And then it stages another one on. We have motorised valves in each of the units, so they're actually turned off. When that unit is not being used, it's isolated from the system and provides the hot water that is required. And so it stages on and off. And then what actually happens is we also then have a rotation system. So they're not that same one that starts all the time. We have a different unit that turns on. So as you can see below on the left-hand side down, you can see that as that first one runs through 24 hours, the second one will take over and become the first, and that stages through and goes around every 24 hours. So in this next picture is just a picture straight from some live sites, looking at the amount of burner capacity that's been operating. So this just has 3 50-litre water heaters doing a reasonably large an apartment site in Melbourne. And as you can see, the green one, which happens to be number 3, but that's where it started. So the green one is operating, you can see on the left-hand side. And full burn capacity is 500 and minimum is like down there around about 25. And as you can see, it's going up and down to meet the load. And as you can see, at this site, a block of apartments, the green one is doing most of the work and the red one is just dropping in. That's the second unit in this group of 3. And you can see it's kicked in a few times to help out during the time. As you can see that in the green, there's this little low piece. I don't have a pointer, so I don't know how to get to there. Is there? Oh, pointer. Oh, yes, there we go. As you can see in this little, thank you very much. As you can see in this little section there, you can see that's overnight where the thing is just idle along. So the unit is actually just matching the heat loss that's being used inside the system. So it turns on just to match the load. And then after 24 hours, the green one turns on. The red one's been doing a bit of work and it takes over to do the major. And the blue one comes in to assist. And then you move on to this point here and then the blue takes over. And the green comes back in again. And all this time sitting in here, the green is turned off. It's doing absolutely nothing. The heat exchange is cold. It's absolutely doing anything. There's no energy being consumed or used at that time. And then, also, one of the really interesting things is the flow rate through the system is fairly constant. And with the tankless design, they're all in parallel. But this is that flow rate on the same thing. The burner's going up and down. And you can see the same things, the unit's coming on, but the flow rate through the unit, as you can see, the blue's doing absolutely nothing here, red's doing nothing, the green's doing nothing here, and the red's doing nothing here. As you can see, there's absolutely no flow rate through any of these other units. But it's fairly constant, so the pressure loss through the system is really constant. You know, you've got a system running at about 500 kPa, and it varies by about 15 kPa, so no one would ever know. So it works really well. There's no major pressure losses through the system. You're not using pressure to change everything. You're using electronics inside the unit. And then we have a dual pump system that connects in. I won't go into any detail. The latest, electronic, automatically connected into the system. We can rotate between the two pumps using the same methodology, and it can be all linked into our BMS system. Last thing, we have an IoT system. So one of the really interesting things is that we have this IoT system that automatically looks at all the functions inside. So if you can imagine you go to a continuous flow water heater, I can look at inside a computer. I remember sitting inside the offices in Kobe in Japan, and I'm looking at a site in the ACT that they were having a problem. We had a person on site, and I could tell them they're on the site trying to work out why this unit's not working. I could tell them that the pumps are not working. The primary pumps on this site are not working. We could see that there was no flow inside the units. All the valves inside, the motorised valves, are all in the open position. We could see that all on the screen. And we knew that when the pumps were turning on, the backflow on the pump must have been faulty, and it was just going round in circles, not going through the unit. So I'm sitting inside Japan and I knew what was wrong. We've had a couple of sites where we've lost gas, and we ring them up. And you go, do you realise you're going to have no hot water soon? The gas is turned off. We can tell that. We get an email notification. It tells us exactly what's going on, and then we run with that. It's really, really interesting. You ring up the client then rings up and goes, do you realise, when your energy companies that are dealing in apartment blocks, what's going on? They ring the site. Oh, didn't we tell you the gas is off? We could tell them before anybody knew. When instead of having them having the clients ringing them saying, I've got no hot water, they already know. If they ring, they can look at the system and says, must be a problem elsewhere because it's not a problem with the plant on that site. So yeah, lots of different things we can do. And it's a really simple connection. Turn on the power, plug it in, and it all works. And one of the things we say, if you don't know the unit's down, do you have a redundant system? Unless you know that it's failed and have been notified, the system's not really redundant. And that's one of the important things. And then, there's 120. So every single component inside the water heater, I can look at. I can look at whether it's open and closed, how many burns it has. There's 120 different items that we can look at any one time. Very useful for commercial plumbers, maintenance, before they even turn up on site. They know what's going wrong. We send out, I can monitor any of those things, and let's say you've got something that's a bit intermittent, we can put it on, we can run it, and we can pull off a CSV file, and we can have a look at it, and we can understand what's going on and how it's working. Then. So one of the things, the most probably interesting thing I was going to talk about is, one of the things is we measure the amount of energy that's being consumed by the plant as a total and as individual water heaters. And I'm taking a grouped one of this, how much energy is being consumed by this plant. We cross-reference that with the meters that are going on. A couple of the places we've got IoT systems on, we've actually run through and we've said, this is how much it's working, and they've looked at their gas meters and gone, yeah, it's within reason. You know what I mean? Sometimes it's hard to see, but it's close to the range. So this is a 250 apartment block building that we've got in New South Wales. And so it just gives you a bit of and what we do is we can look at the average amount of usage that it happens. And so we're looking at this as hourly. And I actually, interestingly enough, always look at weekends as well as weekday. And you can see the peak, which you probably would, sort of slightly moves between week and weekend. And that data there's over a year's data. So it ends up being fairly smooth. One of the other ones is not a year's data, so you don't see. And there's a few things we can look at, and this tells us the maximum that ever occurred at any one time. I can pull that out of the data. I can also look at what the average is, the max, and then what I do is do a calculation of standard deviations. So I look at all the data, I do a standard deviation of what that is, and then I usually do a 5 or a 6 standard deviations. Now, 5 standard deviations is about 1 occurrence every 32 years. I know Mr. Zhang was talking about probability. So this standard deviation, so we look at the average, we look at what the standard deviation is, and we multiply 5 of those on. 1 standard deviation is about 33, 3 standard deviations is 3 in 1,000, 5 deviations is once in every 33 years. It's about once in every so many million. So in essence, it gives us a sense of where we think the worst thing could ever happen. One of the interesting things is, this is a new apartment block. We estimate about 24% will be in the worst hour. Actual we'd ever got for the worst peak was only 14%. And this has had 65 litres per apartment. We've got about 4 of these, and it's about 18 months worth of data. This is 150. This is a really short. This has only been about 6 or 8 weeks, but I didn't have something in the middle because I've got different ones. So I've just grabbed this data. It was the only one I had, and I wanted to get it out daily data. So we looked at this one, and as you can see, it's not quite as smooth as you would expect yet. After a while, some of those smoothed out. The peaks will still occur. Some greater peaks will happen, but it'll smooth out. So that gives you a sense. We've got the worst ever 20 minutes that have ever occurred, what we expect is the maximum, and what the average is so far. So we're just gaining data. This block of apartments is the same one as you saw the first one where we had the 3 units operating. This has got 3 units in here. It's actually a replacement plan. It's 15 years old. I don't know if you probably didn't remember what I said last time, but the maximum lasted about the maximum we got was about 24% in that large block. This 60, the maximum is around about 33%, or actually 25 weeks, estimate that would be 23%, 33%. As you can see, the diversity is dropping off as you're going down small in numbers. And then this site had a 30% reduction in energy use, and I'll talk to you about later how some of that occurs, but it's really good, and that's the data we got and the data they've got. So you can see again weekend, weekday variations. And then this is a 19, so it's a really old one in Sydney, and it's over 30 years old. It happens to be in Elizabeth Bay. You can imagine all single studios. When you have a look at it, you can see now we're looking at 30%. Again, as you go down smaller, diversification. This is something that I think you would probably expect to see, what we were not, but it's really good that the data absolutely shows out the same as what you would expect. The smaller a number of units, the greater the less the diversification. All the apartments have about the same. I think the last one had 61. This has got 57. So as you can see, it's a little bit more peaky in its energy use, in its maximums, because of the smaller apartment block, less diversification. I put this one. This is a short stay hotel. Japan has a different market for different locations. So if you've been to Japan a long time, you'll see these. They're called love hotels, and because people live intergenerational inside really, really small houses, if somebody wants to be intimate, they tend to go to these short stay apartments, 1 hour or 3 hour. And so I grabbed the data from, because I thought it was interesting. People might thought it was interesting. So one of the funny things is on the weekend, I thought this jump at 9 o'clock in the morning was interesting. They must race out, use the hotel. It was sort of really interesting. So, but yeah, but it seems to be late at night and during the weekday, during lunchtime. So I'm thinking maybe they meet up with their wife or partner during the day at lunchtime. So, but it was just... So yeah, anyway, so it was just an interesting data. Some of the things is a different style of hotel, but when you're thinking about applications, we need to think about all sorts of different applications. And this was a hotel within there. And as you can see, you need to make certain you have plenty of hot water 133 litres on average, not including the peaks, per day. So they use a fair bit of hot water there. And now then, my last slide. So this is a fairly standard tourist hotel. I actually stayed in this place in Tokyo. Average room, 81 litres a day, and that's its peak load. This is, I got the raw data from. I have the raw data for quite a few different ones out of the Japanese for different types of applications. And what I'm doing is looking at that in relation to the data that we get inside of it. We don't have any love hotels, but we do have this other one. But I sort of, just for a bit of interest to get you to smile, I put the other one up. And so we looked at where that sits in the same size, looking at the same sizing. You know, they've got over 1,000 units, sites that have been measured, and so one of the things to do, I thought I want to make certain that when we look at the way we do it, make certain we're doing it somewhat similar to them. I think that's my last slide. Yes, yeah, let's just go back to it. So in essence, we are gathering data on water usage in 20-minute peaks, looking at what the peak is and looking at what the average is. And it gives the ability for us to size correctly for different sizes. Thank you.
Thank you, Peter. If I can just, well done. If I could sort of kick off with a question, all this information that you're establishing, is this available to architects, engineers, and plumbers, etc., so that when they're designing products, they can look at the peak usage, etc.?
We can supply some of that data out. Some of the things we do is that when we're looking at a plant that we want to put in for a specific job, for a specific size, we're using the data that we have rather than going, oh, this is what we've always done. We've stepped back and go, what is the data saying? And then using this data to make certain that we always provide the ability to have some redundancy left over in it. So we say, this is where we're going to do it. We put some extra plant in, depending upon the size, to make certain if one goes down, we still could always provide the amount of hot water that's required.
And Dux does a lot of the design work.
Yeah, we would provide that information through to plumbers.